Have you ever noticed how some apps open instantly while others feel painfully slow? GraphQL is one of the technologies that makes modern apps feel fast. Today we'll break down GraphQL in simple terms, compare it with the REST API, and you'll see why Meta has been using GraphQL for all their mobile apps since 2012. GraphQL is an open-source query language for APIs. It's simply an alternative to REST, a different approach to building an API, a different way for clients like mobile apps to ask servers for data. GraphQL isn't a backend framework. You still rely on your usual framework like Express or Django. GraphQL is the layer you add on top of your backend to define your schema and handle data queries. The schema becomes the contract between the client and the server. It tells the client what fields exist and what can be queried. On the client, such as a mobile app or a web app, you can explore and request the exact data you need. You send a single query that describes your ideal response, and the server returns a JSON object that matches that shape. This is the core idea behind GraphQL. Instead of server deciding what data you get from fixed endpoints, the client, your UI, asks for exactly what it needs. The query you write literally mirrors the structure of your screen. It is even written on the GraphQL official website that it is unapologetically built for front-end engineers, aligning with their way of thinking how views are structured and how data is consumed. Traditionally, mobile developers consumed APIs using REST. It's built around the concept of resources, which are represented by different endpoints on the server. For example, if we want to show a user profile in the app, that includes the profile info, latest posts, and friends count. We'll need to make 3 separate requests in REST and then merge them on the client. In this example, each request is under-fetching the data we want. On the other hand, in GraphQL, we can just make one query and specify the exact data we need without underfetching or overfetching. It's perfect for complex queries and optimizing network performance. GraphQL and REST are similar in the fact that they both commonly use HTTP under the hood and usually return results as JSON. But there are a lot of differences. Let's break them down. REST is familiar to most developers and works well for simple, crude APIs. But GraphQL can take some time to get used to. You need to understand schemas, queries, and resolvers. Another big difference is versioning. With REST, when the API changes, you often need new versioned endpoints like v1/users or v2/users to avoid breaking existing clients. GraphQL is completely versionless. It enables you to evolve your API without versions by adding new fields and types, deprecating old ones with a single API version. Caching also works differently. REST has simple URL-based caching that works out of the box. GraphQL caching is trickier because every query is unique, even though it goes through the same endpoint. You need smarter, client-side libraries like Apollo that can cache the individual pieces of data and stitch them together for different queries. Error handling in REST usually uses HTTP status codes, so a 404 or 500 tells you something went wrong. With GraphQL, you usually get a 200 status even if there is an error, because the errors are included right in the JSON response. And finally, tooling. With REST, you usually rely on documentation to know what endpoints exist and what data they return, although nowadays tools like Swagger can generate that automatically. GraphQL is even easier because it's self-documenting. You can explore the API directly in tools like GraphQL and see exactly what queries are possible and what data you can request. All GraphQL tools and libraries are open source, by the way. And finally, the nice part is that GraphQL can even be layered on top of existing REST APIs, letting you slowly adopt it without rewriting everything from scratch. Now, let's break down how GraphQL actually works using an Instagram post as an example. First, there is the schema. It defines all the types, fields, and how they relate to each other. So, for an Instagram post, the schema might say that a post has an ID, an image, a caption, an author, and a list of comments. Separately, we have user and comment types. So the schema is basically like the map of what data exists and how it is connected. The next components in GraphQL are the resolvers. These are the functions behind the scenes that tell GraphQL how to fetch the data for each field. Resolvers are usually implemented on the backend and can be written in any programming language and pull data from anywhere. A database, microservices, basically anything. So, when a mobile app asks for the author of a post, the resolver goes and gets that information and returns it. Then we have the query. This is defined by the mobile app itself. The app might say, give me the post ID, image, caption, author name, and the first 5 comments. And the server responds with a JSON containing exactly that. Next, GraphQL also supports mutations that are used for creating or updating data. For example, when you like a post or add a comment, that goes through a mutation. Additionally, we can implement real-time updates. GraphQL can push updates to the client using subscriptions. So if someone comments on a post while you're looking at it in the app, you get that new comment instantly without refreshing. To do this, you need to implement subscriptions on top of your GraphQL server, typically using a persistent connection like WebSockets or server-sent events, because GraphQL itself doesn't handle real-time delivery. Now, let's talk about the mental model behind GraphQL, how you're supposed to think about it, especially when you're building mobile UIs. In GraphQL, your UI basically is your query. A developer specifies exactly what data each screen or component needs, and the query they write mirrors the structure of the UI. With GraphQL, you model your business domain as a graph. That's exactly how the official documentation puts it. You define types or nodes and then describe how they connect. That way your schema becomes this shared language between your app team and backend. Another powerful thing is strong typing. In GraphQL, every field on the schema has a defined type. That gives you safety. Your tools can check your queries before they run, and you always know what shape of data you're getting back. Now, let's talk about how to integrate GraphQL into a mobile app. On iOS or Android, it's pretty straightforward. You usually use libraries like Apollo iOS, or on Android there is Apollo Kotlin. Both of these libraries generate type-safe models straight from your schema, so you don't have to manually write data models. The schema becomes your source of truth, and the generated code keeps everything in sync as your API evolves. Once Apollo is set up, sending a GraphQL request is easy. You write a query file, the tool generates Swift or Kotlin types, and then in your code you just call the client and get JSON results. It also handles caching out of the box. So when you open a screen like a feed, the app can instantly show cached data while the network request is still loading. Pagination works great too. Since the client controls the data shape, you can define exactly how you want to paginate in your query, using cursors, limits, whatever your backend supports. Mutations on mobile also look the same as queries, just separate files with different operation types. You send the mutation and Apollo updates the cache and your UI reflects the change automatically. That's really the whole idea. Mobile apps benefit a lot from GraphQL because the UI becomes the driver of data. You ask for exactly what the screen needs, nothing more. And because you're sending less data over the network, you save bandwidth and improve battery life. So, if you're building a modern mobile app, GraphQL helps you deliver smoother, faster experiences. And that's exactly why companies like Meta have been relying on it for years. Alright, thanks for watching, don't forget to like and subscribe, and see you in the next one.